Back to Mr. Hassan's Maths channel. I'm now answering the final question from the January 2023 Pure Mathematics P3 exam for the International A-Level Edexcel. This question here is question number 10, and we have a question about a population of fruit flies which is being studied. The number of fruit flies F in the population T days after the start of the study is modeled by this equation. F equals 350 times e to the power of k times t over 9 plus e to the power of kt, where k is a constant. Use the equation of this model here to answer parts A, B, and C. Okay, so it says find the number of fruit flies in the population at the start of the study. So t days after the start of the study. So at the start of the study, t is equal to 0 days. So t is equal to 0. So the number of fruit flies is going to be 350 times e to the power of 0 times k, which is 0, over 9 plus e to the power of 0. Now, anything to the power of 0 is equal to 1. So this is 350 times 1, which is 350, over 9 plus 1, which is 10, which gives you 35. So we can say that the number of fruit flies was 35. So, okay, the number of fruit flies is equal to 10. 35. 10. 35. Okay, that's a nice, simple answer, just worth 1 mark. Then it says, given that there are 200 fruit flies in the population 15 days after the start of the study, show that k equals 1 over 15 ln 12. Okay, so 15 days after the start of the study, we got to show that k is equal to 1 over 15 ln 12. Okay, so now that means when t equals 15, f is equal to 200. So I can just replace those values into this equation and then find the value of k. So we have 200 equals 350 times e to the power of, you have k times t, so it's going to be 15k divided by 9 plus e times, you'll have 15k. Okay, and we have to solve this equation. So what we can do is you can multiply both sides by 9 plus 15, 9 plus e to the power 15k. So we have 200 multiplied by 9 plus e to the power of 15k is equal to 350 times e to the power of 15k. So I can see that straight away. You can divide both sides by 10, so you have 20 and 35, and by 5 as well. So this is going to be 4 times 9 plus e to the power of 15k equals 7 e to the power of 15k. I've just divided both sides by 10 and then by 5. All right, so now we have this equation. So we can find the value of k. So we have to basically expand this bracket. So we have 36 plus 4 e to the power of 15k equals 7 e to the power of 15k. We can bring the e to the power of 15k's together. So this is going to be 7 minus 4, which is 7 e to the power of 15k minus 4 e to the power of 15k. On this side we have 36. So 36 is equal to 3 e to the power of 15k. We can divide both sides by 3. 36 divided by 3 is 12. So you have 12 equals e to the power of 15k. Now we want to find what k is and show that k is 1 over 15 ln 12. So what we can do is we want to free this k from this power. It's in the index. So we do that by taking log to the base of the thing which it's being raised to, or the base that it's been raised to. So it's log to the base e, which is ln. So if you take ln of both sides of this equation, this side becomes ln 12, this side becomes just 15k, because ln of e is 1. Right, so you use the power law, 15k times ln e, which is 15k times 1. So now we can divide both sides by 15, so therefore we can say k equals 1 over 15 times ln of 12, which is what we were required to show, 1 over 15 times ln 12. Okay, so this is our answer for part B. Okay, now we're going to go on to part C. Now for question 10 part C. It says, given also that when T equals capital T, the number of fruit flies in the population is increasing at a rate of 10 per day. Find the possible values of this capital T, giving you answers to one decimal place. So they're talking here about a rate increasing at a rate of 10 per day. Okay, so we're talking about the population, the rate of increase of the population with respect to time per day. So we're talking about what we can say df dt. So basically they're telling us that df dt is equal to 10, okay, at the time when the time t is equal to capital T. So in order for us to solve this problem, we have to find the df dt. We have to take the function f in terms of t here, and we have to find the df dt. We have to differentiate it. Now, the df dt is going to be found here by using what's called the quotient rule, because we have two separate terms. One is the numerator, one is the denominator. There's no like chain rule for the whole thing. The whole thing is like a quotient of two separate functions. So for the quotient rule, what we're going to do is going to use the formula v times u dash minus u times v dash over v squared. So what you do is you write the numerator, which is 350 times e to the power of kt. Now we know that k already is, as we found earlier, is 1 over 15 ln 12. Okay, 1 over 15 times ln 12. But instead of having to write that down everywhere, I'll just write down k and just put that in the end in its actual value when we need to find the answer. All right, so u is 350 e to the power of kt, and v is 9 plus e to the power of k times t. So u dash is going to be basically the differential of this. Now, when you differentiate e to the power of something, it doesn't change. So this is going to be 350 times e to the power of kt. Okay, it's going to be exactly this. Now, I've left a space here. Why? Because you have to also multiply this by the differential of what's inside the function. That's from the chain rule. So we have to multiply this by the differential of k times t. And that gives us basically just k. So that's going to be 350 times k e to the power of kt. All right, and for this one, when you differentiate this, well, the 9 is a separate term. So when you differentiate 9, it becomes 0. But e to the power of kt becomes, for the same reason, e to the power of kt stays the same, but then you multiply it by k, so you have k e to the power of kt. Now, the 350 here is part of this whole term. That's why it's written down in the answer. The 9 is not part of the whole term. These are two separate terms, so this differentiates separately, and the differential of a constant is 0. All right, so now we can use the rule for the quotient rule. These two multiplied together minus these two multiplied together divided by v squared. So I'm going to multiply these two together, so I'll have 350 times k e to the power of kt minus, times, first you've got to multiply by that. That's times 9 plus e to the power of kt minus these two multiplied, which gives you 350 times k. And you have e to the power of kt multiplied by itself, so that's going to be squared, over, all of that over v squared, which is 9 plus e to the power of kt, and this bracket is squared. So that's the df dt. Let's simplify it. I can see when I expand this, I'm going to have 350 e to the power of times k e to the power of kt squared, all of that. We're going to have these two, 1 plus 1 minus, so they'll cancel out actually. So that will make life a bit easier. So let's just expand that bracket, and then that will help to sort that out. So we have 9 times 350. So we're going to have 9 times 350. That gives us 3,150. So 3,150 times k e to the power of kt. You have to be very careful not to leave anything out here. And then 350 times this, which will be plus 350 times k, and you'll have e to the power of kt, all of this squared, all right, because it's like this multiplied by itself, minus, again, 350 times k e to the power of kt squared, all over 9 plus e to the power of kt, all squared. So these two will cancel out because they're the same thing, but just one positive, one negative. So we're left with an expression for df dt. df dt is 3150 times k e to the power of kt over 9 plus e to the power of kt all squared. And we know that when t equals capital T, df dt is equal to 10. So I can now replace the t with capital T and the df dt with 10. So I've got basically 10 equals 3150 k e to the power of kt over 9 plus e to the power of kt all squared. If I multiply both sides by this to get rid of the fraction, I have 10 times 9 plus e to the power of kt all squared equals 3150 e to the power k times, so I have to be careful not to miss anything out, k times e to the power of kt. The 10 cancels with this 10 there, so you're left with 315. So we have to expand this bracket. This is going to give me 81 plus 9 times this times 2, which will be 18 e to the power of kt plus, and you have e to the power of kt all squared, okay, equals 315 times k e to the power of kt. So we're going to have some sort of a quadratic here. So this is e to the power of kt squared plus 18 e to the power of kt minus 315 k e to the power of kt. So it's not quite like terms here. This has got a k associated with it. Plus 81 equals 0. So I'm going to say let u equal e to the power of kt, just to make it a bit more familiar as a quadratic. This will then become u squared plus 18u minus 315 times ku plus 81 equals 0. So we have a quadratic, and this is like our u term. So you have u squared plus, let's take out 18 minus 315k times u plus 81 equals 0. So we could solve this quadratic equation using the quadratic formula. This is like our a is like 1, our b is like 18 minus 315k, and our c is like 81. All right, that's 1 times u squared plus this times u plus 81. So we can say that u is going to be minus b, so it's going to be negative of this, which will be 315k minus 18 minus b plus or minus the square root of b squared. So it's going to be this squared, so it will be 18 minus 315k all squared minus b squared minus 4 times a times c, which is, that's 81, all of that over 2a. So that's going to give me two values. 2a is 2 times 1. All right, so now remember, we know what k is. K is 1 over 15 ln 12. We already worked that out in the earlier part, but I'm not going to write that everywhere, so that's why I'm saving this to the end now. So we can now use the value of k in here, and we can find two values of u using this, hopefully. So let's take this. So what I'm going to do in the calculator, I'm going to take 1 over 15 ln 12, 1 over 15 times ln of 12, and that's, I'm going to store that as a. Okay, so that's going to be a in my calculator now. So I don't have to keep typing that every time. I can just use the a in my calculator. So here I have 315 times a minus 18. In fact, before I do that, let me make my whole fraction. So 315 times a minus 18 plus, I'll start with the plus, the square root of 18 minus 315 a, so I'll put shift, that's a. Okay, and this should be in a bracket actually, because this whole thing has to be squared, so let me put a bracket there. 18 minus 315a, and that whole bracket is squared, minus 4 times 81. Okay, all over 2. So that should give me one of my solutions for u, which is 31.621. Okay, 31.621 continues. I can even store that if I want as b. Okay, so I can call this b in my calculator. All right, and then the other value of u is going to be by changing this here. So let's go back to the answer here, and let's change this to a minus. Okay, so that gives us 2.5615, 2.5615, and I can even store that as C. Right now, so that's C. So now we can find what, we have to find what capital T is. So here we know that basically this is, yeah, so this should have, I should have made this into capital T at this point here actually. Well, anyway, this is capital T now. This is going to be capital T. I should have actually put a capital T, but no problem. In the end, we can do it. So we have basically e to the power of kt, e to the power of kt is equal to 31.621, and e to the power of kt is equal to 2.5615. So I can take ln of both sides to get to release this t from this power. So if I take the ln of both sides, this will be k times t equals the ln of 31.621, and here we'll have kt equals the ln of 2.5615. So t is going to be ln of 31.621 over k, and also the ln of 2.5615 divided by k. So our values of t will be, so we can take the ln of b, okay, divided by k, which is I stored as a, and that gives me 20.848. So at 20.848, and t equals, and this will be the ln of c over a. So I'll do here, I'll change this to that gives me 5.6779. 5.6779. Now, how do they want us to round our answers? To one decimal place. So I can say, therefore, t is equal to 20.8 and 5.7. Those are the two values of t, okay, which solve this problem. Okay, and that's the answer to this whole question. Okay, so that completes this question and completes this whole paper, which was the January 2023 Pure Mathematics P3 International A-Level paper. Other questions from this paper can be found in the playlist that will be posted over here. You'll see the link for it over here. Other questions from this topic of, I guess, is to do with exponentials and logarithms and differentiation. So I guess exponentials and logarithms I'll put here, differentiation I'll put there, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.